is number 4 on the construction packet. So we have to make a rhombus with, I'm going to make this segment look more like the packet, that side and the given angle. And I'm going to lock all this into place before I start, because otherwise it'll slide around. So before you start, you have to think about your plan. So if that's your angle and this is your side, you have to know some, it's actually not too hard. Think about a sketch first. You would take your side, make a straight line with a straight edge, and then you would pick a point on that straight line and you would copy the angle. That's what I would do first. And then you would take the compass and you would measure how long your side is and mark it off here and here. Does that make sense? And then once you get that, you would put your compass here and mark it the same side there, and put your compass here and mark the same side there, and you get your 4th intersection. So I'm just trying to do a scratch work of what my process is going to be. I'm going to start with the angle, and I'm going to copy it. So the black, this is what I have to work with. But what I'm trying to tell you guys is if you take time to start with a sketch, you probably will save time instead of just starting right with the compass. Like, make a plan in your head. And so I'm going to use my compass, and I'm going to take my straight line, and I'm going to just copy my angle down here. That's what I'm going to do. I'm going to copy my angle. Okay, so I'm going to take my compass, and in order to copy the angle, I have to put an arc over the angle. So I'm just going to make an arc. And it's better to make the arc nice and big because you have less error. If you use little tiny arcs, you don't have a lot of accuracy. Now you're going to take your compass and you're going to do the same thing here. So let's say we're going to call our rhombus RHOM. I'm going to make this R, point R. So I'm going to make a big arc here. And now I'm going to pick up my compass, and I'm going to go back to the intersection point, and I'm going to, oh, I wonder if it's too wide. So that can happen to you too, so I have to start over, right? Because my compass doesn't reach my big arc, so I got to start again. So unfortunately that happens. I could press undo also, or I could just get rid of it. Okay, so smaller angle. Still, you don't want it too. Think that's going to be better. So now I'm going to come over here and make the same size arc. And now I'm going to pick up my compass, and I'm going to measure the opening of the arc. So I have to get and see how wide it is, and measure the opening. And this is a little bit that's fidgety on the smartboard, but I think that's pretty close. So you get that opening. Now you go to this intersection point here, and you mark your intersection, and if you miss, then you just go back to your first one and you draw it a little longer. So I have to re-get that measurement and make it a little longer. Does that make sense? So that's my angle. So I'm going to now use that angle, intersection point, to mark off that angle. So you take a straight edge, and I just take the line tool, and you connect from the intersection point to create the angle. So it should be right there. Do you see that? Okay. That's the hard work. Now you just go back up to your segment and figure out how long it is. So I'm just going to take my compass, and again, I may have to adjust my picture because I have this little tiny compass, so let's pretend, I don't think my compass is going to fit that. I should have planned ahead there, so let's pretend my segment was a little shorter. Does that make sense? How my compass is limited there? Okay. You would actually, that could happen with some of your little tiny compasses. Okay, so then you just bring your compass to R, and you swing an arc here, and that could be H, and then you swing it over here, and so somewhere up here would be RH, this would be O somewhere in here, and this would be M. So far I have 3 of the 4 points on the rhombus. Do you see that? You okay with that? But I know my rhombus is going to have this fixed length. So now I'm going to put it here. This is where I think a lot of you, by watching, can save time. You don't have to make parallel lines. Raise your hand if you make parallel lines. It's way more work. You're not the only, I can't believe you're the only one. Nobody else did parallel lines? Okay? You don't have to make any parallel lines. Look at your work and see. All you need to do is go like this from that vertex and come to this vertex and go like this, not quite like that. And if they don't intersect, go back. It should. Just try again a little farther. And that gives you the point O. So your rhombus, you would just take a straight edge now, and then your rhombus goes from here to here to here. Oops. Here, 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 and there. That's your rhombus.
I accidentally did a trapezoid.
It said rhombus though, right? Did I make a mistake?
It said rhombus.
Okay.
I did trapezoid.
Okay, Stephen, I'm going to pause this so we can... Okay, so on number 3, you have an angle, and you're making a parallelogram. There's a lot of different ways to do things correctly, but I think what maybe it was Kate was doing yesterday was a really nice, clean way to do number 3. You have a diagonal, so we'll make a diagonal. I don't know if that was one you were doing yesterday. Yeah, a diagonal of a parallelogram, and then there was an angle. So, and it was an acute angle. So let's just say it's like about like that. So for number 3, that's going to be my diagonal. And we're going to make a parallelogram or a rhombus. Which one is it? Okay. So I would think again like what my plan is. And so one thing that Kate did that I thought was really nice was she copied the angle first. And it can backfire, like there could be a situation where you do this and you might realize you put your next step too far away. But what she did was she just made a parallel line. Because you know that you're going to have a parallelogram. So she actually copied this angle like at a random point up here. and then did a construction to get a parallelogram, 2 parallel lines, and then she put her compass here, and then took the length of the diagonal and did a big sweep, and where it swept, she found the other side. So I just thought I was trying to teach you can like sketch it out first and then try to do it, and you save so much erasing. So that's a great way. It's not the only way, but it's a great way. That way works nice. Okay, let me shrink the idea, okay, and then we'll try to follow it. Okay, so I'm going to just start with a line again. You would start with your straight edge. So just a random line where you're going to copy your angle. And I'm going to get my compass again. So I'm going to just put my compass on the angle and open it. And
You don't have to do it exactly. I kind of just don't.
well, in order to do the construction, I'm going to need to start at the beginning. So I do have to do it. So then I'm going to come over here and copy the angle. So I put my compass there, and I copy the angle. So that means I have to bring my compass back and figure out the opening. So I'm going to shrink it down and get the opening. And then take that measure here and mark the angle off. So I've got my angle. Move the compass out of the way and draw a line in from the vertex through that intersection and make that line nice and long. Now you're going to just take the same measurement. Well, it's easy to use the same measurement again because you're going to make a parallel. So I'm going to just put my compass here again, or I can do it down here, but it's easier to see what I'm going to copy the same angle again, and so I'm going to try to get it so it doesn't go off the screen. Open it up so I can still get the same width. I'm going to use that measure again. And come over here and just swing an arc. And now I'm going to mark the point where I put my compass. And then go back and measure the opening of the angle one more time. So, and that's it right there. Okay, pretty good. So if I check, then I'm going to mark it off here this time. So now I have a parallel line. That's the hardest part. Okay, once you have the parallel lines, you put your line tool in. There's a slight error there on mine. I didn't do a perfect job of connecting that. Can you see that? Slightly off. So really, if I were doing this on a test, I would probably erase and get it right. Okay, but I think for the process, then if you can follow what I'm doing, I'm going to just continue. Because before you get to focus on accuracy, focus on process. And then when you're good on the process, focus on accuracy. So now I'm going to measure the diagonal length. Let's make it blue. So I know it's that size. And I'm just going to stick. My diagonal has to go from here somewhere. So I'm just going to draw an arc. And that should give me the vertex of the parallelogram. That's one of the vertices. So the other one would be here and here. Do you get that so far?
Yeah.
So then I would, and the last one's here, right? Because these are the same size. But it has a little bit of an error because I didn't do a great job of copying that first angle. But now the idea would be, this is my parallelogram. but there's a little bit of an error.
Wait, what's that green line out there?
That helped me get the parallel lines. So I'm going to pause up. So let's look at number 5, the triangle problem. So I need an angle and an altitude, right? So it says, like, here's an altitude, and then it has a slightly obtuse angle, right? All right, it's not going to let me cut that. So we're doing what kind of triangle? Isosceles, and that has to be the altitude?
Yes.
So, oh yeah, that's a good one. So you copy the angle first. So if I were going to sketch it out, I'd copy the angle. But I know if it's isosceles, that I would want to find the angle bisector of this angle. So I'd like do an angle bisector. But if it's an isosceles triangle, the angle bisector is also the altitude. So I would take the length of the altitude and mark it off. And then I put my compass here, and I would like make a perpendicular go this way. And then I would extend my triangle lines.
Wait, okay. Perpendicular.
Because the altitude and the angle bisector in an isosceles triangle are the same.
And altitude, okay, I don't hold that altitude.
Do you want me to, so should I do it?
But how do you get those lines equal length?
Okay, let me do it. Did you kind of understand the idea though?
Yeah, that's what I did.
Okay, so I'm going to just, to orient it that way, I'm going to keep my first line kind of like that. And let's just erase this now. So I'm going to force you guys to think this way now. I'm going to copy my angle with my vertex being, let's call it triangle tri. I'm going to make this the top of it. So I'm going to take my compass and I'm going to copy this angle. See if my compass is going to be wide enough to measure that. Looks like it's going to make that one. Yeah, it is. Okay, so undo. Make sure I still have the same opening. And I do. Oh, wait, I don't. So because I adjusted, I want to make sure. Okay, so I'm going to copy the angle. I'm going to put my compass here and make an arc. Does that make sense? And now I'm going to copy this measurement. Did you say no?
No, I said, oh.
Okay. So I'm going to open it up. I'm going to lock it into place. See, that's the disadvantage that I have. Your shapes don't actually move. So I'm going to try to get this measurement. And this is where the smartboard's a little hard for me to get exact. So that's about as close as I can get. So I'm marked there. So now I'm going to come over here and swing an arc. And that's where I know to draw. Josh, what are you doing? Do some. I'm not even going to respond. Not going to respond. Okay, so there's that. So I've got the angle. Okay? That's one part. I guess so to me it's more work than the rest of this. So now I'm going to go over to this and measure the length of the altitude. Okay? So I'm going to bring it over here and I'm going to swing an arc. So I know the altitude has to be on this arc somewhere. That's how the altitude has to be somewhere on this arc. Okay? But it has to be an angle bisector also. So what I could do is just come over here and use the green mark that's already there and figure out where the middle of that angle is by going to both sides of that.
And you just go more than halfway, right?
And go more than halfway. And so I know now my altitude line has to hit the red line, but it has to go through the black intersection point I missed.
Wait, can you also do that line?
So it has to be like that. Do you see that? And so it would go through here and there. It would go through, it has to go through the vertex, and it has to go through the intersection point, but it's going to stop here because that's how long the altitude is. You see that?
Yeah.
The rest of you guys see that?
Wait,
So the altitude's going to basically start here and end here.
we can also find the middle of that altitude, like the red line, by measuring to the end of.
Yeah, the reason I didn't use these points is my compass wasn't big enough. It would have been easier, but I could already tell my compass was too small. So I just had to use something else. So now I'm going to take this point right here and make a perpendicular going in this direction, right? Because it has to be perpendicular. The altitude has to be perpendicular to the base. So I'm going to make a perpendicular right now.
Wait, from the base.
I'm going to make a perpendicular. So if I use the highlighter, maybe here's the altitude, okay? And I'm going to make a perpendicular. So I'm just sketching it in, but I want a perpendicular here because the altitude has to hit. So that's going to become my base.
Okay.
Okay?
So where are you making the perpendicular?
From where the altitude line hits the angle bisector.
Okay.
So I'm just going to go more than, I'm going to make like a circle, basically, around that point and go more than halfway to make a perpendicular. So I'm going to just open this up and go more than halfway and do that on both sides. And get it there. And then my new line, that's going to be where my base is. So my base has to go through this point, and that point.
Wait, why did you make the circle?
Well, I had to make a perpendicular.
That's a lot of lines.
It is. You have to kind of practice. Like, these are big thinking problems. Like,
Thanks.
but if you watch it again or try it again, it's going to make more sense. So I've almost got my triangle, right? So you're going to take your straight edge and you're going to complete your triangle now by taking those original points and extending them until they hit. Ooh, I just made it. Barely. If I didn't. So, and then you would have to extend. Oops. So you would extend. All right, I can't get this to draw there. So you would extend this, and you would have your triangle. Get rid of these little guys here. Cut. You see that? That's a hard problem. I mean, these are hard. Now you can see that the constructions, they require a lot of brain activity.
Would it be the same for equilateral?
So let's try that equilateral triangle one. I think it's a little easier. Was that number 6? Let me sketch it out and then. So you have an altitude, and the goal is to take this length and make an equilateral triangle where that's the altitude. So here's what I was telling kids yesterday: is just make a random equilateral triangle with any length you want, okay? Any length. Yep, any length. And then put your compass here and swing an arc below. And then put your compass here and get a perpendicular. And then you would have this perpendicular, okay? And then take this length and mark it off. So maybe it's that long, all right?
Yeah.
And then, so it's actually easier because the rest is the same. Now you're going to use this point and make a perpendicular about this point. So you would construct a perpendicular in this direction. And then you would do the same thing. You would just extend the red part of the triangle because you have a 60-degree angle. Or you could construct a 60-degree angle first. So somebody asked me this yesterday, and I said I would make a 60-degree angle first. But then somebody asked me again, and I thought, oh, I should just use my 60-degree angle. Do you see how that's kind of the same? No? Do you need me to do
So
it?
you just
So just make a random, watch.
Yeah, I see what you're doing. And then you just mark off where the altitude is.
Yeah,
And then you just extend the.
right. Does anybody need me to do this? Everybody understands? So if I gave that to you on a test, you could do that. So the quiz, no, it's an equilateral triangle with a specific height.
I know. Well, we did that, but we did it in a complicated way, like Josh. It was complicated.
So imagine you have a quiz and you have to do 4 to 5 constructions. Being complicated is probably a bad strategy because you might not finish the quiz.
It was fast.
4 to 5 construction.
And I have to be able to understand what you did. It can't. No. I don't want you to bring it up right now. You can show me after class. But trial and error is not going to be the way you get points. So just try to think of a process. You know what I mean? You just want to have a plan. Okay, let's do number 8. So it says you've got this segment, and that's the base. Oh, that's one of the congruent sides of an isosceles triangle. And then you also have an angle. I'm just thinking about how I would do that. So an acute angle, that is one of the base angles. So do you know what that means?
What is the angle of the base angle is the.
So if I were going to sketch it, the base angles are the matching ones.
Oh.
Okay, but the side they gave you is one of the congruent sides. Because it says given the segment below as one of the congruent sides, and an angle is one of the base angles, construct an isosceles triangle. So how about, maybe just by me drawing that you could do that. How about you take this side length,
Okay, so I.
and then you copy the angle right at the base of it. And then you swing this side length, right? Until it intersects. Do you want me to do that?
I mean, I got the. Okay, so I drew the acute angle, like the one that you have up there on the right,
Yeah, so do you want me to do it?
or yeah.
And then maybe that'll help you answer your question. So I would copy the angle like you copied the angle. It sounds like we would have done the same thing.
Yeah.
So you have to like have a line, right? And then you take your compass and you bring it over here, and you're going to make an arc on that angle. So make an arc, right? Yes? Ready? Okay. So then,
Okay, I got it.
okay, but you have to watch if you ask the question, right? So then you're going to go back up here and measure the opening of the angle. So this is again the part that's a little less accurate up here. So I'm going to take the compass now and measure that opening. Okay? I'm going to draw a line. And my line is going to go from my vertex. Oops. Try again. Through there. Okay, and then I have to take my compass now and bring it up here to figure out how big the side is. So I have to open this up to get a fit. So I have to change this.
Wait, it might fit.
It's not gonna fit. Okay, so let's shrink it. Let's just pretend it was smaller to begin with. Okay, so there we go. So like that. And I know it's one of my congruent sides, right? So I'm gonna mark that off up here, which gives me the vertex. Right?
Connect the dots.
Well,
Because then you do that side, you do that congruent side too on the outside.
well, you got to think a little more, actually. Like, there's a couple different ways. You know, here's something to think about. And you guys can tell me if you have another idea. But I know the three angles of a triangle make 180 degrees, right? So if I imagine out here, so if I imagine out here, that I could extend this line for a minute, all of my thoughts through. This is the sum of the other two angles, right? The remaining angles in the triangle. So if I copy this little angle one more time up here, the leftover would give me the top angle.
So,
But why would you need the top angle?
Well, because how are you going to put...
another angle there.
But I already have the side length.
Yes, I can.
Yeah. No, I was making it harder. I already have the side length, so I just swing down like I originally said. Although, I just lost my focus. Sorry about that. I was thinking of a different...
Could you also do it from the other function?
I could have done what I was just saying, but that would have been a really hard way to do it.
Oh, I get it.
So are those side lengths the same? They look different, don't they?
No.
Holy crap. Oh, they are the same.
Could you also have done it where, like, you just swing the point, like, where you copy the angle, and just also make the length?
No. So good question. Let me put this in before I lose my focus again.
Yeah.
So this is it, although I didn't get it quite right. Let's try one more time. So the reason is, Maddie, it said that this length here has to be the equal lengths. And these angles had to be on the base.
Oh.
It said there's the congruent angles and the congruent
Oh, I
sides.
just read it because it said as one of the base angles, so I just made it one.
Oh, did it?
Yeah.
Oh, but in an isosceles triangle, the term base angle, so that's something I should have clarified, means the congruent angles.
Okay.
Do you guys get that? That's really important to clarify.
Oh, but that's only for like an isosceles, right?
Yes. Whenever you hear base angle combined with the term isosceles, it means one of the two congruent angles.
Oh, okay. So they have to.
Right.
Any side of the base?
Okay, so when we're talking about isosceles, those terms are very specific. So that might be something new to add in. So when we talk about isosceles triangles, base angle is one of the two congruent angles, always. So it's not just an angle at the bottom. It could be anywhere, but it's one of the congruent. Like if I drew a different isosceles triangle that was like this, these are the base angles, even though that's not resting on them. So the isosceles base angles are the ones that are congruent. Okay? All right.